Tonight, we're going to explore 12 of the strangest, most unsettling, and most genuinely mind-altering philosophical theories ever proposed about the nature of reality. Not thought experiments you can dismiss with a laugh. Real, serious ideas. Ideas that have occupied the greatest thinkers in human history. Ideas that, when you sit with them long enough, in the dark, begin to do something to the way you see the world. Here is what the 12 theories have in common. Every single one of them takes something you believe without thinking about it. That the world is real, that you have free will, that other people are conscious, that the future will resemble the past, that the self you call you persists from day to day and shows you that you cannot prove it. Not because these beliefs are wrong, but because the foundations we build them on are not as solid as we assume. The universe you think you know, the reality you navigate every day, your memories, your choices, your sense of being a continuous self moving through time. All of it turns out to rest on assumptions that philosophy cannot fully verify, and that science, at its edges, finds genuinely mysterious. By the end of tonight, you're going to understand the Boltzmann brain, why the most probable version of you in an infinite universe is a floating brain with fake memories that popped into existence seconds ago. You're going to understand solipsism, the argument that you cannot prove anyone else exists, and why it has never been successfully refuted. You're going to understand the simulation hypothesis, the problem of other minds, eternalism and the block universe, the hard problem of consciousness, moral anti-realism, the problem of induction, the ship of Theseus and personal identity, Zeno's paradoxes of motion, the experience machine, and the Boltzmann brain's cousin, the fine-tuning problem that asks why the universe is calibrated for life at all. Each of these theories is its own universe. Each one opens a door that is hard to close once you've walked through it. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. The best philosophical theories have a specific quality. They are not complicated for the sake of complexity. They are simple questions with implications that spiral outward until they encompass everything. The best ones start with something you already believe and end somewhere you never expected to go. Tonight's journey starts with you, lying here, reading these words, certain of at least one thing, that you exist. From that single certainty, 12 theories will build themselves around you and show you just how strange the universe you inhabit actually is. In 1895, the Austrian physicist Ludwig Boltzmann was trying to explain why the universe has an arrow of time. Why does time move forward? Why does entropy, the measure of disorder, always increase? Why does a glass shatter but never spontaneously reassemble? His answer involved a concept called statistical mechanics. In a universe governed by probabilistic laws, any configuration of matter is possible. Most configurations are high entropy, disordered, chaotic, simple. But over an infinite amount of time, low entropy configurations will also appear, randomly, by chance. Organized structures will spontaneously form in a sea of chaos, not because something caused them, but because in infinite time, even the most improbable events occur. Boltzmann suggested that our entire observable universe might be one of these random fluctuations, a pocket of order that spontaneously appeared in an otherwise eternal, high-entropy void. The planets, the stars, the laws of physics as we experience them, all of it a temporary, improbable fluctuation in a cosmic background of maximum disorder. Later, physicists took this idea further and asked a disturbing question. If random fluctuations can produce ordered structures, what is the smallest, simplest ordered structure that could spontaneously appear and have conscious experiences? The answer is a brain. A single, isolated brain, floating in space, with no body, no world around it, no past, but complete with false memories, sensory experiences, and the subjective sense of being alive. This is the Boltzmann brain. Here is the argument in its most unsettling form. In an eternal universe, random fluctuations produce all possible configurations. A full universe with planets and history and physics is an extraordinarily complex configuration. A single brain with fake memories is an incomparably simpler one. Simple configurations are vastly more probable than complex ones. Therefore, in an eternal universe, Boltzmann brains, isolated conscious minds with fabricated experiences, are far more likely to exist than genuine observers embedded in real universes with real histories. This means that if our universe is eternal, or if we exist within an eternal multiverse, the statistical expectation is that any given conscious observer is almost certainly a Boltzmann brain. You are more likely to be a free-floating mind with false memories of having read philosophy and eaten breakfast and driven to work than you are to be an actual human being with a real continuous history in a real physical world. The false memories feel exactly like real memories. The sensory experience of lying here feels exactly like what lying here would feel like if you were actually lying here. The Boltzmann brain cannot tell it is a Boltzmann brain. It has no access to the truth of its own origin. It simply finds itself conscious, with experiences and memories that feel genuine, in a body that might not exist, in a world that might be a ghost. You might say, "This is absurd. I am clearly a real human." But think carefully about what clearly means here. Your certainty rests on your memories and experiences, which are exactly the things the Boltzmann brain hypothesis says could be fabricated. The argument that you are a real human uses evidence that the argument says cannot be trusted. This is what makes the Boltzmann brain problem genuinely serious, rather than merely fun to contemplate. It is not just a weird thought experiment, it is a challenge to the foundations of scientific cosmology. If a cosmological model, a theory about the universe, predicts that Boltzmann brains are more likely than real observers, then that model is considered defective. Any theory of the eternal universe that generates more Boltzmann brains than genuine observers is, in the jargon of cosmologists, falsified by the existence of you. Physicists Sean Carroll, Alan Guth, and others have written seriously about this problem. Various solutions have been proposed. Perhaps our universe is not eternal. Perhaps the multiverse has a specific structure that suppresses Boltzmann brain production. Perhaps some feature of quantum cosmology prevents the fluctuation from producing isolated brains rather than full, consistent universes. None of these solutions is fully satisfying. The problem remains open. Lie here for a moment and consider what it would mean if you were a Boltzmann brain. The experience would be identical to the one you are having now. Every memory of your life, every relationship, every emotion you have felt, all of it would be a false imprint, a statistical artifact, a random configuration of matter that briefly organized itself into something that feels like a life. You cannot rule it out. Not absolutely, not with certainty. The universe is strange enough that even this cannot be dismissed. Descartes sat down in 1641 with a single goal: to find something he could be absolutely certain about. He decided to doubt everything, every belief, every perception, every memory, and see what survived the most extreme skepticism possible. He doubted his senses. They had deceived him before. He doubted mathematics. Perhaps an evil demon was manipulating his thoughts. He doubted the physical world. Perhaps it was all a dream. One by one, every belief was stripped away. What remained, after everything was doubted, was one single certainty: the fact that he was doubting. Thinking requires a thinker. To doubt is to think, and to think is to exist. Cogito ergo sum. I think, therefore I am. Descartes stopped there and used this foundation to rebuild his worldview. But some philosophers took the same method further and refused to stop where Descartes stopped. They pointed out that the cogito proves only one thing: the existence of your own consciousness. It proves nothing whatsoever about anything else. This is solipsism, the philosophical position that only one's own mind is certain to exist. Everything else, the external world, other people, the past, the future, is, strictly speaking, unverifiable. You know you are conscious. You cannot know, with equivalent certainty, that anyone or anything else is. The problem of other minds makes solipsism not just a philosophical curiosity, but a genuinely hard problem. How do you know that other people are conscious? You observe their behavior. They report having experiences. Their brains look similar to yours. But all of this evidence, every piece of it, arrives through your own perceptions, processed by your own mind. You cannot step outside your mind to verify it against an external reality. The mind is the only instrument you have, and you are trying to use it to evaluate claims about things outside itself. This argument is not obviously wrong. In fact, it has never been successfully refuted. The most common responses are pragmatic rather than logical. We have no reason to suppose that the behavioral and neurological correlates of consciousness in others do not indicate consciousness. The simplest explanation for other people's behavior is that they are conscious. Solipsism is technically unfalsifiable and therefore practically useless. These are sensible responses, but notice what they do not say. They do not say solipsism is false. They say it is impractical to believe, or that there is no good reason to believe it, or that the alternative is simpler. They concede the logical point, while urging us to move past it for practical reasons. Bertrand Russell, one of the 20th century's most rigorous thinkers, said that solipsism is logically tenable but psychologically impossible. He meant, you cannot actually believe it, because belief in other minds is baked into how human cognition works. But he acknowledged that it could not be strictly disproved. The neuroscientist Christoph Koch has a more modern version of this problem. He notes that the only mind he has direct access to is his own. Every inference he makes about other people's consciousness is indirect, based on behavior, neural activity, verbal report, but never on direct access to their experience. From within his own consciousness, the consciousness of everyone else in the world is an inference, not an observation. Now lie here and look at this from the inside. Every person you have ever known, every conversation you have ever had, every moment of apparent connection with another human being, all of it was, strictly speaking, an inference. You experienced your own side of those interactions directly. You inferred the other person's inner life from their behavior and words. There is no way to get behind that inference. No technique that lets you experience someone else's consciousness from the inside. The barrier is not technological, it is logical. Every piece of evidence about other minds passes through your mind to reach you, and your mind is what is supposed to be verified. You might be the only conscious being in existence. Everything else might be an extraordinarily detailed construct of your own awareness. The universe might be, in the most literal sense, your dream. You cannot prove otherwise. This is not a comfortable position to sit with, but it is an honest one. In 2003, philosopher Nick Bostrom published a paper in the Philosophical Quarterly that contained a surprisingly clean argument for why we might be living inside a computer simulation, not as science fiction, as a serious philosophical and probabilistic claim. The argument goes like this. Consider three possibilities. First, virtually all civilizations go extinct before developing the technology to create realistic simulations of conscious minds. Second, virtually all civilizations that reach that technological level choose not to run such simulations. Third, we are almost certainly living in a computer simulation right now. At least one of these must be true. They cannot all be false simultaneously. Here is why. If civilizations routinely survive to develop simulation technology, and if they routinely choose to run simulations of their ancestors or of conscious minds in general, then the number of simulated minds would quickly come to vastly outnumber the number of real minds. If the ratio of simulated to real conscious minds is 1,000,000 to 1, then any given conscious mind, including yours, has only a 1 in a million chance of being a real one. If you have no special reason to think you are real rather than simulated, you should assign your probability of being simulated at roughly the same ratio as simulated to real minds in the universe. For the third option to be false, one of the first two must be true. Either civilizations almost never survive long enough, or those that do almost never choose to run simulations. Bostrom suggested calling this the simulation argument, and noted that it did not tell you which of the three options was true, only that at least one must be. Elon Musk, speaking at a conference in 2016, said the probability that we are in base reality is 1 in billions. David Chalmers, arguably the world's most respected philosopher of mind, has written seriously about the simulation hypothesis in his book Reality Plus, arguing that even if we are simulated, the simulation is real in all the ways that matter. The physical objects in a simulation are real physical objects, just implemented in a different substrate than we assumed. What would it mean to live in a simulation? The laws of physics as we experience them would be the simulation's rules, its code, its constraints. The fact that physics has laws at all, that it is mathematically describable, that it behaves consistently and can be predicted by equations, is actually more consistent with a computational substrate than with brute, uncaused physical existence. A simulation would have exactly the properties our universe has: mathematical regularity, finite information processing speed, the speed of light, quantum discretization at the Planck scale, and no accessible outside. Some physicists have taken the simulation hypothesis seriously enough to look for computational artifacts in the structure of space-time, signatures of a grid or a rounding error that would be detectable if the universe were being computed at a finite resolution. No such signatures have been definitively found, but the search itself says something about how seriously the idea is taken. If you are a simulated mind, what follows? Your experiences are as real as they would be if you were not simulated. The simulation generates genuine qualia, genuine consciousness, genuine everything. Your relationships are real. Your suffering and joy are real. The only thing that is different is the substrate. Instead of quarks and electrons, your mind runs on some pattern of computational states in a system you cannot observe. The simulation might have a purpose. It might be a historical reconstruction, an experiment, an entertainment, or something with no analog in any concept we possess. It might be running on hardware that is nothing like what we imagine as hardware. The beings who run it might be incomprehensibly different from us, or they might be strikingly similar, our descendants. Looking back, the simulation could be paused, it could be reset, it could be ended. The now you are experiencing could be interrupted at any moment by an act outside the simulation itself. Or it could run on indefinitely. You have no way to know. What is certain is this: if the simulation hypothesis is true, the universe is not what it appears to be. The deepest layer of reality is not matter and energy. It is information, computation, code, and you are one of its outputs. The stars you see when you look up, the galaxy you live in, the billions of years of cosmic history before your birth, all of it might be computed on demand, rendered only when it needs to be observed, stored as compressed data when no observer is looking. You cannot see the code, but the code may be all there is. In 1995, philosopher David Chalmers gave a name to what he called the most baffling problem in the science of the mind. He called it the hard problem of consciousness, and it remains, 30 years later, completely unsolved. The easy problems of consciousness, which are not actually easy, involve explaining cognitive functions. How does the brain process visual information? How does it integrate signals from different senses into a unified experience? How does it direct attention? How does it produce language? How does it store memories? These are difficult scientific questions, but they are in principle answerable. They are easy only in the sense that we know what kind of answer would count as a solution. Some account of brain mechanisms and information processing. The hard problem is different. The hard problem asks, why is there subjective experience at all? When you see the color red, there is something it is like to see red. A felt quality. A redness. Something subjective and immediate that is not captured by any description of how your visual cortex processes wavelengths between 620 and 750 nanometers. When you feel pain, there is something it is like to feel pain. The distinctive phenomenology of hurting, which cannot be fully described by any account of nociceptor activation and C-fiber firing. This felt quality of experience, what philosophers call qualia, is the hard problem. Why does the brain's information processing produce any experience at all? Why isn't it all just computation in the dark, with no inner light of awareness? What is the relationship between the physical processes in the brain and the subjective experience those processes generate? This is not a question that neuroscience is close to answering. It is not a question that we know how to approach scientifically. We can measure brain activity. We can correlate brain states with reported experiences. We can identify neural correlates of consciousness, the specific brain patterns that accompany specific experiences. But explaining why those patterns are accompanied by experience at all, rather than just happening in the dark, that is the hard problem, and we have no framework for solving it. Chalmers argued that the hard problem might require a fundamentally new kind of scientific explanation, one that goes beyond the physical. He suggested that consciousness might be a fundamental feature of the universe, like mass or charge, irreducible to anything more basic. This view, called panpsychism in its various forms, holds that mind or experience is a basic property of reality, present in some form even at the level of fundamental particles, combining and integrating in progressively more complex ways to produce the rich conscious experience of human beings. Panpsychism has a long philosophical history. Leibniz, Spinoza, Whitehead, and many others have held versions of it. In recent years, it has experienced a serious revival among professional philosophers and even some neuroscientists. Giulio Tononi's integrated information theory, which we have discussed in other episodes, is a mathematically rigorous version of panpsychism. It proposes that consciousness is identical to integrated information, present wherever there is integration, from the simplest neural circuit to the most complex brain. The alternative views are equally difficult. Physicalism, the view that everything, including consciousness, is ultimately physical, needs to explain how subjective experience arises from purely physical processes. Functionalism, the view that consciousness is a matter of functional organization, what the system does rather than what it is made of, has trouble explaining why any functional organization produces experience rather than just computation. Dualism, the view that mind and matter are fundamentally different substances, is almost universally rejected by contemporary philosophers because it cannot explain how mind and matter interact. But the hard problem makes the alternatives look no better. We are left with a genuine mystery. The most intimate fact about your existence, the fact that there is something it is like to be you, is the thing that science and philosophy cannot explain. The redness of red, the painfulness of pain, the particular quality of this moment, lying here, hearing these words, being in a body in a dark room with the weight of a night around you. All of that, the phenomenology of being alive, remains, after centuries of inquiry, fundamentally unexplained. The universe has produced matter, energy, stars, planets, and chemistry. Out of chemistry, it has produced biology. Out of biology, brains. And out of brains, somehow, inexplicably, it has produced this: the experience of being, a universe that is aware of itself, through you. And we do not know how. Einstein's theory of special relativity, published in 1905, changed the way physicists understand time. It showed that the passage of time is not universal. Clocks run at different rates depending on their relative velocity. And what counts as now for one observer is not the same as now for another observer moving at a different speed. This was strange enough. But the deeper implication, developed by Einstein's former professor Hermann Minkowski in 1908, was stranger still. Minkowski showed that special relativity is most naturally understood as a theory about a four-dimensional space-time, a single geometric object in which time is a fourth dimension alongside the three dimensions of space. Past, present, and future exist as locations in this four-dimensional block, just as different places exist as locations in the three-dimensional space we are familiar with. In the block universe, nothing becomes, nothing passes, nothing flows. The past does not cease to exist when you are done with it. The future does not come into being when you reach it. Everything that has ever happened and everything that will ever happen exists simultaneously, frozen in the four-dimensional geometry of space-time. Your birth is there. Your death is there. This moment right now is there, as permanent and real as a location in physical space. and the moment of your first word, and the moment of your last, and every moment between them, and every moment before your birth and after your death. All of it exists, in the block, right now, fixed and unchanging. The sense of time flowing, the subjective experience of a present moving through the past toward the future, is, on this view, an illusion. Or rather, it is a feature of consciousness rather than a feature of reality. The moving now you experience is not a moving spotlight illuminating a series of events that otherwise exist only in potential. It is the experience of a conscious mind progressing through a static four-dimensional structure. The structure itself does not move. Only your experience of it does. This view is called eternalism, or the block universe, or four-dimensionalism. It is the view most naturally implied by general relativity, which extends Minkowski's geometry to incorporate gravity and the curvature of space-time. Most physicists who think carefully about the implications of relativity for the metaphysics of time tend toward the block universe view. The implications are profound and deeply unsettling. If the block universe is correct, the future already exists, not in the sense that it is determined or inevitable. Determinism is a separate question, but in the sense that future events have the same ontological status as present events. They exist in space-time as fixed locations. The moment of your death exists right now, as a real physical location in four-dimensional space-time. You will reach it not because it comes to you, but because you are moving through space-time, and that is where your world line, your path through the four-dimensional block, ends. Free will, in this picture, does not mean the future is open. It means that your choices are part of the fixed geometry of space-time, and that you are the mechanism by which certain future locations in the block are reached. The future is fixed. So is your decision-making process. Both are equally real. The philosopher and physicist Janan Ismail has written beautifully about the block universe and the human experience of time. She argues that the sense of moving through time, the lived experience of the present, is not an illusion in any dismissive sense. It is a real feature of what it is like to be a conscious being embedded in space-time. The experience of passage is generated by the structure of memory and anticipation in a conscious mind progressing through a static four-dimensional world. What is illusory is the metaphysical specialness of now. The idea that this moment has a distinguished status that other moments, your birth, your death, the year 1066, the year 3000, do not. In the block universe, all of them are equally real. All of them exist. The now is just where you happen to be. Lying here tonight, in this moment, you are at a specific location in four-dimensional space-time. The moment before this one exists, behind you in the block, still as real as when you were in it. The moment after this one exists, ahead of you in the block, equally real, equally there. You have not yet reached it, but it is waiting. Everything that will ever happen to you is already real. You are moving toward it. And when you close your eyes tonight and slip into sleep, that moment is real too, already inscribed in the geometry of space-time. Already there, waiting for you to reach it. The philosopher David Hume was sitting alone in his study sometime around 1740 when he noticed something that had been staring at humanity since the beginning of thought and had somehow never been confronted directly. He was thinking about causality, about why we believe that one event causes another, and he realized that we have no logical justification for this belief at all. Here is the problem. You see the sun rise every morning of your life. 1,000 mornings. 10,000. You conclude that the sun will rise tomorrow. But what is your justification for this conclusion? Past experience. The sun has always risen before, therefore it will rise again. But wait, that reasoning is circular. You are using past regularities as evidence for future regularities. But the assumption that future regularities will resemble past ones is exactly what needs to be justified. You cannot use the reliability of past experience to justify relying on past experience. That is not a proof. It is a circular appeal to the very thing being questioned. This is the problem of induction. We have no non-circular justification for inferring from past experience to future expectations. Science itself, the entirety of the scientific enterprise, rests on induction. We observe patterns. We generalize from those patterns. We make predictions based on those generalizations. Every scientific law, every physical constant, every engineering application of physics, all of it assumes that the laws of nature that held in the past will continue to hold in the future. That what worked yesterday will work tomorrow. That the universe is uniform over time. We cannot prove this. We can only assume it. Hume's response to his own discovery was remarkably clear-eyed. He said that while we cannot rationally justify induction, we cannot help but do it. The habit of expecting the future to resemble the past is built into human cognition at a level deeper than reason. We are inductive reasoners by nature, not by logic. Custom and habit, not rational argument, are the foundation of our beliefs about the external world. This is both liberating and terrifying. Liberating because it means we should not be paralyzed by the impossibility of certain knowledge. We can live and function and build science on the foundation of reasonable assumptions, even without proving them. Terrifying because it means the entire edifice of human knowledge about the physical world rests on an assumption that the future will resemble the past. That cannot be proved and might conceivably be false. Karl Popper, in the 20th century, tried to sidestep the problem by reformulating science as falsification rather than induction. We do not confirm scientific theories by accumulating positive instances, he argued. We simply fail to falsify them. A theory is scientific if and only if it makes predictions that could conceivably be proved wrong. Science progresses not by proving things true, but by eliminating the false. This is elegant and enormously influential. But it does not solve Hume's problem. Even Popperian falsificationism assumes that if a theory is falsified by an experiment today, it will be falsified by the same experiment tomorrow. That consistency, the regularity of the experimental outcome, is itself an inductive assumption. The American philosopher Nelson Goodman took the problem further in 1955 with his new riddle of induction. He invented a predicate called GRU, meaning green if observed before the year 3000, blue if observed after. Every emerald you have ever seen has been GRU, in addition to being green. Both all emeralds are green and all emeralds are GRU are equally supported by the observed evidence, but they make contradictory predictions about emeralds observed after 3000. How do we choose between them? Why is green the natural category rather than GRU? Goodman's riddle shows that the problem of induction is not just about the number of observations. It is about which regularities to project into the future. And we have no purely logical basis for preferring some regularities over others. We choose the natural categories, the ones that carve nature at its joints, as Plato put it, by habit, intuition, and evolutionary predisposition, not by logic. Tonight, lying here, consider that every expectation you have about tomorrow, the sun rising, gravity continuing to hold, your phone working, your memories remaining continuous, is based on induction, on the unprovable assumption that tomorrow will be like today, that the universe will not change its rules overnight. It always has continued. But that, of course, is an inductive argument. The legend says that Theseus, the hero of Athens, sailed his famous ship to Crete, slew the Minotaur, and returned victorious. The Athenians preserved his ship for centuries as a monument to the feat. But over time, the planks rotted and were replaced. One by one, every board and beam and sail was substituted with new material. Eventually, not a single original piece remained. The Greek historian Plutarch, writing in the 1st century CE, recorded the philosophical puzzle this raised. Was this still the ship of Theseus? If it was not, at which moment did it stop being his ship? Was it when the first plank was replaced? When the last? When half had been replaced? There is no obvious answer. Any line you draw is arbitrary. Thomas Hobbes added a further twist. What if someone had collected all the discarded original planks and reassembled them into a ship? Now, 2 ships exist. Which one is the ship of Theseus? The continuous one, which never ceased to be a ship but has no original material? Or the reconstructed one, which has all the original material but was not continuously maintained? This is the ship of Theseus paradox, and it applies to you with a directness that makes it immediately personal. You are made of atoms. Those atoms are replaced constantly. The cells of your gut lining are replaced every few days. Your red blood cells last about 4 months. The neurons in your cerebral cortex persist longer, some for your entire lifetime, but the molecules within them turn over continuously. Most of the atoms in your body today were not in your body 7 years ago. The physical substrate of which you are composed has largely been replaced many times over. Yet you feel continuous. You identify with the child in your earliest memories as yourself. You feel that the person you were at age 10 and the person you are now are the same person, connected by a continuous thread of identity. What is that thread? Not the atoms. We have established that. Not even the cells in most cases. Philosophers have proposed various answers. John Locke argued that personal identity consists in psychological continuity, specifically the continuity of memory. You are the same person as the 10-year-old in your memories, because you remember being that child, or could, if you tried hard enough. But memory is unreliable and gappy. You do not remember being 3 years old. Does that mean you are not the same person as the 3-year-old who bore your name? Derek Parfit took the most radical position. He argued that personal identity is not a deep fact about the world at all. There is no single fact about whether you are the same person as your earlier self. There is just a chain of connected psychological states, some more tightly linked than others. The question of whether 2 person stages constitute the same person is a matter of degree, not of kind. And it matters less than we think. What matters, Parfit argued, is the continuation of the psychological connections themselves, the memories, personality, values, and relationships, not whether those connections constitute numerical identity in some strict metaphysical sense. If Parfit is right, then the you who wakes up tomorrow morning is not numerically identical to the you lying here now. There is just a future person who is psychologically continuous with the present you, close enough that it makes sense to plan for them and care about their welfare. Not so different as to be a stranger, but not strictly the same thing in the metaphysically loaded sense we assume when we use the word I. You might be a river rather than a stone, not an unchanging object that persists through time. A pattern, a process, a continuously flowing sequence of states that we call by the same name for convenience, because the states are connected enough that the naming is useful. If you are a pattern rather than a thing, then your identity is not more secure for being long-lasting. It is more like music than like rock. The music exists only as long as it is being played. Stop playing it, and the music is gone. Start again, and is it the same music? It might be. Or it might be a very good reproduction of something that no longer exists. You go to sleep tonight. The pattern pauses. The music stops. In the morning, it starts again. Is it the same music? You believe it is. So does the person who wakes up. But the belief and the fact may not be the same thing. Zeno of Elea was a philosopher in the 5th century BCE, a student and defender of Parmenides, who held the radical view that reality is single, unchanging, and indivisible. Motion, change, and multiplicity are illusions. To defend this position, Zeno constructed a series of arguments designed to show that motion is logically impossible. Not physically difficult, not practically rare, logically impossible. His most famous argument is the dichotomy. To cross a room, you must first cross half the room. But before you can cross half the room, you must cross a quarter of it. Before the quarter, an eighth. Before the eighth, a 16th. Before any movement at all, you must complete an infinite number of prior movements, each smaller than the last, stretching all the way back to some movement of zero length. But an infinite series of tasks cannot be completed in finite time. To complete infinitely many tasks would require infinitely long. Therefore, you can never begin to move at all. The second paradox is Achilles and the tortoise. The great hero Achilles races a tortoise and gives it a head start. Achilles runs 10 times faster than the tortoise. Achilles quickly reaches the point where the tortoise started, but by the time he gets there, the tortoise has moved forward by 1/10 of its original lead. Achilles reaches that new point, but the tortoise has moved forward again. Each time Achilles closes the gap, the tortoise advances. The gap between them halves and halves again. But since there are infinitely many halvings, Achilles can never reach the tortoise. In reality, of course, Achilles catches the tortoise almost immediately. We know this from observation. So something must be wrong with the argument. But it took 2,000 years for mathematics to provide a rigorous response. The response, developed through the calculus of Newton and Leibniz, and then made rigorous by Cauchy and Weierstrass in the 19th century, is the convergent infinite series. The sum of 1/2 plus 1/4 plus 1/8 plus 1/16, extending infinitely, converges to 1. An infinite number of terms can sum to a finite value. Therefore, crossing a room in finite time is not prevented by the infinite divisibility of the path. This seems to resolve Zeno's paradoxes mathematically. But does it resolve them philosophically? The mathematical resolution says that infinite series can have finite sums. But Zeno's question was about completing an infinite number of tasks, not about whether the distances sum to a finite value. Can you actually perform infinitely many acts in finite time? Or does mathematics describe the structure of the problem without telling you whether the infinite performance is genuinely possible. This is still debated. Philosophers of mathematics distinguish between potential infinity, the unlimited process of subdivision which can go on without end in principle, and actual infinity, a completed infinite totality, a genuine infinitely many tasks actually performed. The mathematical resolution assumes actual infinity is coherent. Some mathematicians and philosophers contest this. There is also a third paradox, the arrow, which cuts at a different point. Consider an arrow in flight at a single instant. At that instant, the arrow is located at a single point in space. It is not in motion relative to anything. It is simply occupying a position, as it would if it were at rest. If at every single instant the arrow is at rest, how does motion exist at all? Motion seems to require time, but if time is composed of durationless instants, motion has no room to exist. This paradox prefigures the modern problem of the instantaneous rate of change, velocity at a point, which calculus handles through the limit of ratios. But again, the question of whether instantaneous velocity is a genuinely coherent concept or a useful mathematical fiction is one that physicists and philosophers still debate at the foundations level. The deeper reason Zeno's paradoxes matter is that they point at something real about the structure of space, time, and continuity. Modern physics has not simply dissolved these questions. Quantum mechanics introduces a discrete structure at the Planck scale. The smallest meaningful length, roughly 1.6 times 10 to the minus 35 meters, below which the notion of a smooth, continuous spacetime may break down entirely. If space is fundamentally discrete rather than continuously divisible, then Zeno's infinite subdivisions reach a hard floor, and his paradoxes are avoided not by mathematics but by physics. Or perhaps reality is continuous, and the mathematical resolution is correct, and actual infinities are coherent, and you do complete infinitely many tasks when you cross a room. In which case, infinity is not something that happens only in abstract mathematics. It is baked into the fabric of every physical movement you make. Either way, motion, the simplest thing in the world, the thing you do without thought, turns out, when examined, to rest on foundations that are genuinely mysterious. Even the simplest thing conceals a problem that has not yet been fully solved. In 1996, David Chalmers introduced a thought experiment that has become one of the most discussed and contested ideas in philosophy of mind. The concept of the philosophical zombie, the P-zombie. A philosophical zombie is a being that is physically identical to a conscious human being in every detail. Same neurons, same brain states, same behavioral responses, same verbal reports of experience. Every photon that bounces off the P-zombie produces the same physical response it would produce in a normal person. Every stimulus triggers the same cascade of neural activity. Every question about its inner experience produces the same kind of answer a normal person would give. But there is nothing it is like to be a P-zombie. The lights are on, but nobody is home. There is no subjective experience, no qualia, no felt quality to any of its processing. It is a zombie in the philosophical sense, complete behavioral and physical equivalence to a conscious being, with zero consciousness inside. Chalmers argues that philosophical zombies are conceivable, that we can coherently imagine them, that there is no logical contradiction in the concept. And from conceivability he infers possibility. If P-zombies are conceivable, then consciousness is not logically entailed by any physical description. Therefore, consciousness is not a physical property. Therefore, physicalism, the view that everything is ultimately physical, is false. This is one of the most contested arguments in contemporary philosophy. The objections come from multiple directions. One objection: conceivability does not entail possibility. We can conceive of water not being H2O, but water necessarily is H2O. It is impossible for water to be anything else, even though the impossibility is not apparent before the discovery of chemistry. Perhaps consciousness necessarily arises from certain physical processes, even if this necessity is not apparent from first principles. Another objection: the conceivability of P-zombies is itself questionable. Perhaps when you try to imagine a being that is physically identical to you but has no consciousness, you are not actually imagining anything coherent. Perhaps the concept of consciousness is defined by the very functional and physical properties that the P-zombie shares with you. And so a P-zombie would by definition be conscious. Dennett argues that P-zombies are not conceivable once you work out the details carefully. If a being gives all the reports of having conscious experiences, if it says, "I am in pain" when damaged, if it behaves exactly as if it were conscious, then what more could consciousness consist in? To suppose that all of this happens without consciousness is, Dennett suggests, simply to refuse to understand what consciousness is. Chalmers' response: Dennett is missing the point. The question is not whether all the functional properties of consciousness are present. The question is whether there is something it is like to be the system. And that question cannot be answered by any description of functional or physical properties, however detailed. There is a further fact about consciousness, the phenomenal fact, that is not captured by any functional description. This debate goes to the heart of what consciousness is, and what kind of explanation could ever account for it. If P-zombies are possible, then there is something about consciousness that is fundamentally non-physical, irreducible to anything in the domain of science as currently practiced. If they are not possible, then consciousness is necessarily physical, and we simply do not yet know what physical processes generate it. The stakes are as high as any question in philosophy. Is consciousness a physical phenomenon that science will eventually explain? Or is it something that requires a different kind of explanation, one that currently does not exist? You know with certainty that you are not a P-zombie. You have experiences. There is something it is like to be you. The redness of red, the painfulness of pain, the quality of this moment. You have direct access to all of this, and it is more certain than anything you could know about the physical world. What you cannot know is whether anyone else is a P-zombie, whether the people around you have the inner light, whether the behavior that looks like consciousness from outside is accompanied inside by anything at all. You are certain of your own consciousness. Nothing else is equally certain. And the fact that you are certain of your own consciousness is the thing that no physical science has yet explained. Most people move through life with the assumption that some things are genuinely, objectively wrong. Not just wrong in their opinion, or wrong according to their culture, or wrong by convention. Wrong in a way that would be wrong regardless of what anyone believed. That slavery was wrong even when most people accepted it. That torture for entertainment is wrong independently of whether any society condemns it. This assumption is called moral realism. The view that there are objective moral facts, features of the universe that make some actions genuinely right and others genuinely wrong, independently of what any individual or society thinks. Moral anti-realism is the denial of this. The view that there are no objective moral facts, that moral claims are not descriptions of mind-independent features of reality. That when you say slavery is wrong, You are not reporting a fact about the universe the way you report a fact when you say the Earth is round. You are doing something else, expressing an attitude, issuing a prescription, reporting your emotional response, or playing a social role. The various versions of moral anti-realism differ on what exactly moral claims are doing, if not stating objective facts. Emotivism holds that moral claims express attitudes. Slavery is wrong is the verbal equivalent of a disgusted reaction, not a fact-stating proposition. Expressivism generalizes this. Moral claims express non-cognitive states like commitments, norms, or plans. Relativism holds that moral claims are true or false, but only relative to a cultural or individual framework. There is no perspective-independent truth about morality. The most radical version, error theory, defended by J.L. Mackie, holds that moral claims do purport to state objective facts, but those facts do not exist. All moral claims are false. There are no moral facts in the universe. Mackie's argument proceeds from two directions. The argument from queerness: if there were objective moral facts, they would be extremely strange entities, metaphysically unlike anything else in the natural world. What kind of thing is a moral fact? It is not a physical property. You cannot detect it with instruments. It has a strange, intrinsically motivating character. If you genuinely perceive that something is wrong, you are thereby motivated to avoid it. But ordinary facts do not come with built-in motivations. The strangeness of moral facts, Mackie argues, gives us reason to doubt their existence. The argument from disagreement: if there were objective moral facts, we would expect moral beliefs to converge, the way beliefs about physics converge. Instead, moral beliefs vary enormously across cultures, historical periods, and individuals. This persistent disagreement is better explained by the absence of objective moral facts than by their presence. The implications of moral anti-realism are profound and deeply unsettling for most people. If there are no objective moral facts, then nothing is genuinely wrong in the universe. Not genocide, not torture, not cruelty to children. These actions are wrong by our standards, by our emotional responses, by the norms of our culture, but not by the universe. The universe contains no wrongness. It contains only events. This does not follow that anti-realists endorse such actions. They can maintain deep commitments to human welfare, justice and compassion, commitments they act on with conviction. The difference is that they acknowledge these commitments as their own, as attitudes they hold, prescriptions they endorse, values they have, rather than as objective features of reality they have discovered. There is something both liberating and vertigo-inducing about moral anti-realism. Liberating because it places moral responsibility squarely on human beings. We cannot defer to a cosmic moral order. We cannot say it is objectively wrong and feel we have accessed some external authority. We have to own our moral commitments as ours, built by our history and culture and reflection, maintained by our choice rather than by any external necessity. Vertiginous because, without objective moral facts, the ground of ethics becomes uncertain. The passionate conviction that certain things are wrong, the conviction that felt as certain as anything, turns out to be, on this view, not a perception of reality, but an expression of how we feel. And feelings, however deep, can be wrong in the practical sense. You can feel certain about things that are not true. The universe, on this view, is morally indifferent. It does not care. It has no preferences. It simply continues its operations. Stars forming and dying, particles scattering, consciousness arising briefly in biological systems, and then ceasing. The wrongness or rightness of things is layered on top of this indifferent universe by human minds that care, for reasons that are ultimately psychological and evolutionary, not cosmic. What you care about is real. The care is real. The commitment is real. But the fact you are committed to the objective wrongness out there in the universe may not be. In 1974, the philosopher Robert Nozick posed a thought experiment in his book Anarchy, State, and Utopia that has remained one of the most discussed in all of moral philosophy. He called it the experience machine. Suppose, Nozick said, that neuroscientists have developed a machine that can give you any experience you desire. Floating in a tank, with electrodes attached to your brain, you could experience yourself writing the great novel of the century. You could experience deep love and perfect friendship. You could experience the joy of athletic achievement, artistic creation, philosophical insight. Every experience would feel exactly as it would in real life, indistinguishable from the genuine article. You would not know you were in the tank, while in the machine, you would believe you were actually living these experiences. Would you plug in? Most people, when they hear this for the first time, feel a powerful reluctance. Even if the experiences would be subjectively indistinguishable from real ones, something feels wrong about the tank. Something feels like it would be missing. Nozick used this reaction as evidence against hedonism, the philosophical view that the only thing that matters for human welfare is the felt quality of experience, that a good life is simply a life of positive experiences and the absence of negative ones. If hedonism were true, you should plug into the experience machine without hesitation. The machine offers maximal positive experience. That is all hedonism values. Reluctance to plug in reveals that we value things beyond experience. What do we value beyond experience? Nozick suggested 3 things. We want to actually do things, not just have the experience of doing them. We want to actually be certain kinds of people, not just feel as if we are. And we want contact with a deeper reality, with the actual world, not just an artificial simulation of it. This argument anticipates the simulation hypothesis and connects to it directly. If we are in a simulation, we are, in effect, in an experience machine. The question of whether this matters, whether a life in a simulation is less good than a life in base reality, is exactly Nozick's question in a different form. Chalmers, in his response to the simulation hypothesis, argues that it does not matter. If the simulation is consistent, if it has genuine physical laws, genuine causal structure, genuine conscious minds, then the experiences it contains are real experiences, and the lives lived within it are real lives. The substrate does not affect the value. What matters is the quality of the experience and the reality of the connections within the simulation, not whether there is a deeper layer underneath. But Nozick's intuition pushes back. There is something about contact with genuine reality, with the actual world, however it is constituted, that seems to matter to us beyond its experiential quality. The truth of the situation seems to matter, even if the experience would be identical with and without the truth. This intuition might be wrong. It might be a bias produced by evolution in a context where accurate perception of reality had survival value, and it might not track anything that matters fundamentally. But it is a widespread and powerful intuition, and its existence is itself philosophically interesting. The experience machine also raises questions about the relationship between value and experience that run throughout ethical theory. If we would refuse the experience machine, if we value the actual world even at the cost of maximal positive experience, then what exactly are we valuing? What is it about contact with the actual world that we care about? One answer: the people in our lives. We value not just the experience of love and friendship, but the actual people we love and are friends with. A simulation of them, however perfect, however subjectively identical, is not them. And we want to be with them, actually with them, connected to them in reality, not just in an experience of connection. If this is right, then what we care most deeply about is not experience at all. It is relationship, connection, the actual other, not the experienced other. And no experience machine, however perfect, can give us that. Lying here tonight, whatever world surrounds you, however many layers of reality or simulation there might be beneath it, the relationships in it are real. The care is real. The actual presence of the people in your life, in whatever the actual world turns out to be, is the thing the experience machine cannot replicate. That may be what matters most. The universe has rules, fundamental constants, numbers that appear in the equations of physics, numbers that determine the properties of particles and forces and the structure of space-time. The gravitational constant, the mass of the electron, the strength of the electromagnetic force, the cosmological constant that governs the expansion of space-time. These constants were not derived from theory. They were measured. Physics predicts how the universe behaves given certain values, but it does not predict what the values should be. The values are simply what they are, discovered by experiment, taken as given. And they are, by any reasonable calculation, extraordinary. The physicist Lee Smolin has estimated that if the fundamental constants were set randomly, the probability of getting a universe like ours, one that permits the formation of stars, planets, chemistry, and life, is roughly 1 in 10 to the power of 229. That is 1 divided by a number, with 229 zeros. Change the gravitational constant by a factor of 2, and stars burn out too quickly for life to evolve. Slightly increase the mass of the electron, and atoms cannot form. Adjust the strong nuclear force by a few percent, and either no elements heavier than hydrogen can exist, too weak, or all hydrogen immediately fuses to helium, and no water-forming chemistry is possible. 2. Strong. Make the cosmological constant slightly larger, and the universe expands too rapidly for gravity to form any structure at all. The universe appears to be calibrated, with extraordinary precision, at a level of fine-tuning that dwarfs anything humans have ever engineered, for the existence of complex structures, for chemistry, for stars and planets, for biology and consciousness. Why? There are 3 broad categories of response, and none of them is fully satisfying. The first is design. The constants were set by an intelligence, a creator, who intended for a universe capable of supporting life. The fine-tuning is not a coincidence. It is a choice. This is the traditional theological response. Its weakness is that it replaces one mystery with another. Who designed the designer? And what are the designer's fundamental constants? The second is the multiverse. Our universe is one of an enormous or infinite number of universes, each with different values for the fundamental constants. Most universes are sterile. Their constants do not permit life. We find ourselves in a universe with life-permitting constants, not because those constants were chosen, but because in universes without such constants, there are no observers to notice. This is the anthropic argument again. Our existence as observers selects for a life-permitting universe. The multiverse provides the probability distribution from which our universe is one sample. The multiverse hypothesis is scientifically motivated by string theory, which predicts an enormous landscape of possible vacuum states, each corresponding to a different set of physical constants. It is also motivated by inflationary cosmology, which naturally produces a vast collection of causally separated regions with different properties. But the multiverse is not directly observable. By definition, other universes are beyond our causal horizon, and its explanatory power depends on probability assumptions that are themselves contested. The third is resignation. Perhaps the constants are what they are for reasons we do not yet understand. Perhaps there is a deeper theory, a theory of everything, from which the constants can be derived rather than simply measured. Perhaps the values we have been told are fine-tuned are actually the only values that any consistent physics could have. Perhaps the apparent fine-tuning is an artifact of our choice of variables. None of these responses is obviously correct. The fine-tuning problem remains one of the deepest and most contested questions in the foundations of physics and cosmology. But here is what the fine-tuning problem tells you. Lying here tonight, the universe you inhabit is by any statistical measure that can be applied to the question extraordinarily unlikely. The fact that atoms can form, that stars can burn for billions of years, that planets can orbit in stable configurations, that chemistry can give rise to biology, that biology can give rise to consciousness. All of this required a set of physical constants that occupy a tiny corner of the space of all possible constants. Whether this is because the constants were chosen, or because there are so many universes that every possible set of constants exists somewhere, or because there is some deeper necessity we have not yet uncovered. The conclusion is the same. The universe arranged itself at its most fundamental level in exactly the way required for you to exist. You are not an accident in the sense of being an afterthought. You are the product of physical constants, calibrated by whatever mechanism to produce you. The universe spent 13.8 billion years building the conditions for your existence. Whatever the universe is doing, it was doing it with a set of rules that, against all statistical odds, made tonight possible, made you possible, and brought you here, lying in the dark, thinking about how strange it all is. Ludwig Boltzmann's life ended in tragedy in 1906. He took his own life while on holiday in Duino, near Trieste, at age 62. His wife and daughter were swimming when he died. He had spent decades battling depression and fighting scientific battles that he felt he was losing. The atomic theory of matter, the idea that all substance is composed of atoms and molecules, was still contested at the time, and Boltzmann was its most prominent champion. He was mocked and dismissed by influential physicists, who found the atomic hypothesis unnecessary. Ernst Mach, a philosopher-physicist of enormous prestige, held that atoms were unobservable fictions that science should avoid. Boltzmann was right. Mach was wrong. 3 years after Boltzmann's death, Einstein published his paper explaining Brownian motion in terms of molecular collisions, providing essentially direct evidence for the existence of atoms. Boltzmann never saw his vindication. The philosophical problem he was wrestling with, the arrow of time, the relationship between macroscopic thermodynamics and underlying microscopic mechanics, remained unresolved at his death, and remains in its deepest form, unresolved today. Why does time have a direction? The microscopic laws of physics are time reversible. A film of billiard balls colliding, played in reverse, is equally valid physics. But a film of a glass shattering, played in reverse, is obviously wrong. Why? Boltzmann's answer involved the concept of entropy and the proposition that the universe began in a state of unusually low entropy. The Big Bang, from a thermodynamic perspective, was an extraordinarily ordered initial condition. The universe has been moving from low entropy to high entropy ever since. And this movement, from order toward disorder, is what gives time its direction. We remember the past and anticipate the future because the past was more ordered than the future. But this answer immediately raises a further question. Why did the universe begin in a state of low entropy? What set the initial conditions? This is sometimes called the past hypothesis, the assumption that the early universe had an extremely low entropy. We do not know why this is true. The second law of thermodynamics tells us entropy increases, but it does not tell us why it started low. The cosmologist Roger Penrose has calculated the entropy of the Big Bang and found it to be extraordinarily special. The probability of a universe beginning with entropy as low as ours, chosen at random from all possible initial conditions, is roughly 1 in 10 to the power of 10 to the power of 123. That is a number so large that it cannot be written out even if every particle in the observable universe were used as a digit. The Boltzmann Brain problem arises when you combine this fact with the possibility that the universe might be eternal or quasi-eternal. In an eternal universe, one that persists for an infinite time, any entropy fluctuation that is possible will eventually occur, no matter how improbable. Given enough time, the entire observable universe could fluctuate into existence from a high entropy background. But as noted above, smaller fluctuations are vastly more probable than larger ones. A single brain is a smaller fluctuation than an entire universe. The modern response from cosmology is to argue for specific models of eternal inflation, in which the probability measure over possible observers is structured in a way that suppresses Boltzmann Brain. Production relative to the production of genuine observers in genuine universes. This requires careful analysis of what it means to assign probabilities over infinite ensembles, a subtle and still contested issue in the foundations of cosmology. What makes this deeply personal is the realization that the question of whether you are a Boltzmann brain is connected to the question of why the universe exists at all in the state it does. The improbability of the Big Bang, the extraordinary low entropy of the initial conditions, the fine-tuning of the constants, all of these are connected. They all point at the same mysterious fact, that the universe you inhabit is by any statistical measure applied to the space of all possible universes or all possible initial conditions, extraordinarily unusual. You are the beneficiary of that unusualness. Your existence depends on it. The atoms in your body could form only because the universe began in a state of low enough entropy for stars to form and fuse hydrogen into heavier elements. Your consciousness requires a brain of extraordinary complexity, which required billions of years of organized stellar and planetary evolution, which required an initial condition that was extraordinarily improbable. The chain of improbabilities that led to you is so long that its product is a number smaller than any number anyone has ever tried to contemplate. And yet here you are, lying here in the dark, the beneficiary of the most improbable chain of events in the history of improbable things. Whatever else is uncertain, whether you are a Boltzmann brain or a genuine human, whether the world around you is real or simulated, whether your memories are true or fabricated, this moment is happening. Something is here. Something is thinking these thoughts. The improbable has occurred, in one form or another. That, somehow, is the least disputed thing in this entire philosophical journey. Descartes' evil demon, the Malin Janey of the Meditations, is the original simulation hypothesis. Descartes imagined a powerful, malicious being that could be deceiving him about everything, about the existence of the external world, about the reliability of his senses, about the validity of mathematical reasoning itself. The demon fills his mind with false experiences, false memories, false certainties. The simulation hypothesis is a modern, secular, technologically sophisticated version of the same idea. Replace the evil demon with an advanced civilization running a computational model of consciousness, and you have Bostrom's argument. The structure is identical. The content is different. The philosophical difficulty is the same. What makes the simulation hypothesis more than science fiction is the mathematical and physical precision with which it can be articulated. The universe we observe has properties that are, in a specific technical sense, consistent with being computed. Quantum mechanics describes physics at the Planck scale. The smallest meaningful length is 1.616 times 10 to the minus 35 meters. The smallest meaningful time is 5.39 times 10 to the minus 44 seconds. The speed of light imposes a maximum information propagation rate. The universe processes a finite amount of information per unit time, per unit volume. These features, discrete structure, finite processing rate, information limits, are exactly the features you would expect of a computational simulation running on hardware with finite resources. Whether they are also the features you would expect of a fundamentally physical universe, governed by quantum field theory, is a separate and contested question. But the point is that the simulation hypothesis is not ruled out by any known physics. Physicists Silas Bean, Zoré Davoudi, and Martin Savage at the University of Washington published a paper in 2012 arguing that if the universe is a simulation on a regular lattice, a computational grid, then the discretization would produce specific anisotropies in the cosmic ray energy spectrum. Cosmic rays arriving from certain directions would show characteristic artifacts of the underlying grid structure. No such anisotropies have been definitively detected, but the measurement is extremely difficult at the relevant scales. If the simulation is running on hardware that is fundamentally different from what we imagine, not a regular Euclidean grid, but some exotic computational substrate, then the observational signatures might be different or absent. We cannot rule out the simulation hypothesis by looking for lattice artifacts if we do not know what the computational substrate looks like. The philosopher David Chalmers has argued in his recent book Reality Plus that the simulation hypothesis, even if true, does not diminish reality. A simulated world is a real world. The objects in it are real objects. The experiences are real experiences. The physics is real physics. Just physics at the level of the simulation rather than at the level of the underlying computational hardware. This is analogous, Chalmers suggests, to how the macroscopic physical world of tables and chairs is real even though it is implemented in the underlying quantum field theory. Levels of description can all be real. This is a reassuring philosophical position. If correct, it means that even if we are simulated, nothing we care about is undermined. Our lives are still our lives. Our relationships are still our relationships. The beauty of the world is still real beauty. But Nozick's experience machine pushes back. Chalmers says the simulation is real. Nozick's thought experiment suggests we care about more than reality. We care about a specific kind of reality, one that is not mediated by an artificial layer. Whether this intuition tracks something genuinely important or is just an evolutionary bias toward a particular kind of truth is itself an open question. There is one further implication of the simulation hypothesis that is rarely discussed but deserves attention. If we are simulated, the beings running the simulation presumably have access to our experience. They can observe our thoughts, our choices, our consciousness. From outside the simulation, there is no privacy. Everything we believe is inner and hidden is potentially observable by whoever maintains the computational substrate. This is not necessarily sinister. The beings running the simulation might be benevolent, curious, indifferent, or entirely unlike us in their motivations. But it is a feature of the simulated condition that has no analog in ordinary physics. In ordinary physics, the interior of a conscious mind is inaccessible to external observation. In a simulation, it might not be. Lying here in the dark, if the simulation hypothesis is true, you are being observed. Not necessarily watched in the way a camera watches, but the state of your consciousness is encoded in the computational substrate, accessible in principle to whatever intelligence operates and monitors it. The private theater of your mind is not private at all. It is data. Perhaps this is not different from being in the presence of a God who knows all thoughts. The theological concept of omniscience is structurally similar, an intelligence with complete access to the interior states of all conscious beings. The simulation hypothesis arrives at the same possibility by a different route. Whether that is comforting or unsettling depends entirely on the character of whoever is watching. The history of attempts to solve the hard problem of consciousness is the history of intelligent people discovering, one by one, that their solution does not work. Identity theory, the view that mental states are identical to brain states, was a serious proposal in the philosophy of mind in the 1950s and 60s. Pain is identical to C-fiber firing. The experience of red is identical to the activation of certain visual cortex neurons. This is clean and scientifically respectable. But it runs into the explanatory gap. Even if pain is identical to C-fiber firing, we still have not explained why C-fiber firing hurts. The identity claim does not tell you why the physical process produces experience. It just asserts that it does. Functionalism, the view that mental states are defined by their functional role, by what they do rather than what they are made of, became dominant in the 1970s and 80s. A mental state is a state that takes certain inputs and produces certain outputs, regardless of whether it is implemented in neurons or silicon or anything else. This solved the mind-body problem for cognitive states. We know what it is for a system to believe something, to desire something, to recognize a pattern. These are functional properties that can be defined computationally. But functionalism does not solve the hard problem. It tells you what mental states do. It does not tell you why they feel like anything. A thermostat has a functional state. It detects temperature and responds. A calculator has functional states. It processes inputs and produces outputs. Neither seems to have any conscious experience. What is the difference between a functional system that has experience and one that does not? Functionalism has no answer. It captures the functional story but leaves out the phenomenal one. Giulio Tononi's integrated information theory is the most mathematically developed response to the hard problem in contemporary neuroscience. IIT proposes that consciousness is identical to integrated information, a specific mathematical quantity, phi, that measures how much information is generated by a system as a whole beyond what is generated by its parts. High phi means high consciousness. Zero phi means no consciousness. IIT is unusual among consciousness theories because it takes the phenomenal seriously from the start. Tononi begins by listing the properties of consciousness as we know it from the inside. It is real. It is structured. It is unified. It is specific. It is differentiated. And then tries to identify the physical property that has all these features. Integrated information turns out to have them. And phi can be computed in principle for any physical system. The implications are startling. IIT implies that consciousness is widespread in nature, present wherever there is integration, in simple circuits, in animals with modest nervous systems, perhaps even in some non-biological systems. This is a form of panpsychism, the view that consciousness is a fundamental feature of reality, not something that emerges only at high levels of neural complexity. The physicist Roger Penrose and the anesthesiologist Stuart Hameroff have proposed a different approach, the orchestrated objective reduction theory, or ORC, which proposes that consciousness arises from quantum computations in structures called microtubules within neurons. On this view, consciousness is not just a product of classical information processing, but involves quantum effects at the subcellular level. The theory remains highly controversial and lacks strong experimental support, but it represents the seriousness with which some researchers take the possibility that quantum mechanics is involved in consciousness. None of these theories has solved the hard problem. They have all illuminated aspects of it, proposed interesting frameworks, and generated productive research programs. But none has explained why any physical or computational process produces subjective experience. The explanatory gap remains. What the hard problem teaches us, at the deepest level, is something about the limits of the third-person scientific perspective. Science proceeds by describing the world from outside, by measuring, quantifying, modeling. It describes patterns in the physical world that are accessible to multiple observers. But consciousness is essentially first person. It is accessible only from inside. No amount of third-person description of a brain, however detailed, however complete, will tell you what it is like to be that brain. Thomas Nagel made this point in his famous 1974 paper, "What is it like to be a bat?" We know a great deal about bat echolocation, the frequency of the signals, the neural processing of returns, the behavioral responses. But we have no idea what echolocation is like from inside a bat's experience. The first-person perspective of the bat is in principle inaccessible to any third-person scientific investigation. The same is true of your experience, from the perspective of anyone else. Everything about your consciousness that is distinctively yours, the particular quality of this moment, the specific feeling of being you, is inaccessible to any observer from outside. It is yours alone. It exists only in the first person. And the most fundamental mystery about the universe is this: where does the first person come from? Why is there something it is like to be anything at all, in a universe that could in principle operate with all the same causal structure and produce no experience whatsoever? That question has no answer that anyone has been able to give. It may be unanswerable, but it is the question that makes everything else possible, including this moment, lying here, wondering. The thought experiment that cuts deepest into personal identity is not the ship of Theseus, but the teleporter. Because the ship of Theseus involves gradual replacement, a slow attrition of parts over time. It allows us to maintain the comfortable illusion that continuity is being preserved throughout the process. We can imagine that identity is like a flame passed from candle to candle. The original flame is gone, but its continuation is present in the new one. The teleporter cuts through this illusion by making the discontinuity abrupt and total. You step in, you are destroyed. A replica steps out. The replica has all your memories, all your personality, all your patterns. But the causal chain was interrupted. The atoms that composed you were disassembled, and new atoms, different ones, were assembled into the replica. Is the replica you? Derek Parfit's most radical thought experiment is not the teleporter, but fission. Suppose neuroscientists can divide your brain and transplant each hemisphere into a separate body. Both halves are equally continuous with the original you. Both hemispheres have equal claim to being the continuation of the original brain. Both resulting people wake up with memories of being you. Both sincerely believe they are you. Which one is you? Parfit's answer is devastating in its simplicity. Neither, or both. The question has no determinate answer. And this is not because we lack information. We have all the relevant facts. It is because the question asks for a fact that does not exist. There is no further fact, beyond the facts about psychological continuity and physical causation, that determines which resulting person is the real continuation. The conclusion Parfit draws from this is that personal identity is not what matters. We care about our own future because we believe that the person who will experience our future is us, is the same entity as the present self. But the teleporter and fission cases show that identity is not a deep fact. Two people can both be equally continuous with you, which means identity is not a one-to-one relation. And if identity is not one-to-one, then identity is not what we should care about. What we should care about, what we actually care about, stripped of the metaphysical mistake about identity, is psychological continuity and connectedness, the survival of memories, the continuation of projects, the persistence of personality and relationships. These things can be present to a greater or lesser degree, and they are what make future persons worth caring about. This conclusion, Parfit said, was both disturbing and liberating. Disturbing because it undercuts the usual basis for self-concern. If you will survive being teleported, if the person who steps out is psychologically continuous with you, but you might or might not be identical with that person in the deep metaphysical sense, then your survival is a matter of degree rather than an all-or-nothing fact. Liberating because it loosens the grip of a certain kind of self-obsession. If personal identity is not a deep fact, then the boundaries of the self are less fixed than we think. The obsessive concern with what will happen to me dissolves somewhat when me turns out not to be a sharply bounded entity persisting through time. Parfit also applied this framework to ordinary life and found it changed his experience of the world. He said that once he understood that his future self was connected to his present self by degrees of psychological continuity rather than by a fact of identity, he began to feel less separate from other people. The boundaries of the self seemed more like practical conveniences than metaphysical walls. Buddhism makes a structurally similar claim. The doctrine of anatta, no self, holds that the persistent unified self that most people experience as their identity is a construction, a mental habit, rather than a genuine feature of reality. What actually exists is a stream of physical and mental events, causally connected, that the mind synthesizes into the illusion of a unified self. There is no self behind the stream. There is only the stream. The convergence between Parfit's analytical philosophy and Buddhist metaphysics is striking. Parfit himself noted it, remarking that he had independently arrived at something close to what Buddhist philosophers had been saying for 2.5 millennia. Tonight, lying here, the person who will wake up tomorrow morning is connected to you by psychological continuity, by the preservation of memory and personality in the physical substrate of your brain. Not identical to you in any deep metaphysical sense, not the same unchanging entity persisting through the gap of sleep, but continuous with you in the ways that matter. And if Parfit is right, that continuity is what matters, then the night's gap, the interruption of consciousness during sleep, does not threaten what is actually important. The important things persist through the gap. The memories, the personality, the relationships, the projects. They will be there in the morning, waiting for consciousness to resume. The you that wakes up will be you enough, and perhaps that is the right relationship to the self. Not clinging to it as though it were a precious, fragile stone that could shatter, but holding it lightly, as a pattern that flows and reforms, that pauses and resumes, that changes and continues. The river is still the river, even though the water is always new. David Hume noticed in 1739, in his Treatise of Human Nature, something that has never been satisfactorily answered. When you examine any moral argument, at some point you move from statements of fact, statements about what is the case, to statements of value, statements about what ought to be the case. But the transition is never justified. No logical inference leads from is to ought. From the fact that something causes suffering, you cannot derive by logic alone that it ought not to be done. You need an additional premise, that suffering is bad, that we should minimize it, and that premise is itself a value judgment, not a fact. This is Hume's is-ought problem, and it has never been solved. Every moral argument, at its foundation, rests on value premises that cannot themselves be derived from facts. You can derive consequences from principles. You can show that one moral view is inconsistent with another. But you cannot, by pure reason, derive moral conclusions from purely factual premises. This discovery leads naturally toward moral anti-realism. If moral conclusions require moral premises, and moral premises are not facts about the world, then moral beliefs are not knowledge of objective facts. They are something else, expressions of sentiment, cultural norms, evolutionary predispositions, practical commitments. J.L. Mackie, in his 1977 book Ethics, Inventing Right and Wrong, built the most rigorous case for moral anti-realism in contemporary philosophy. Mackie accepted that moral language functions as if it is stating objective facts. When we say torture is wrong, we seem to be saying something true about torture, not just expressing our discomfort. But Mackie argued that this is an error. Moral discourse has the surface grammar of fact-stating discourse, but there are no moral facts to be stated. We are all, systematically, making claims that are literally false when we make moral assertions. All moral claims have the form X is objectively wrong, and no X is objectively wrong, because there are no objective values in the universe. The second major argument for moral anti-realism, beyond Hume's is-ought and Mackie's queerness argument, is the evolutionary debunking argument. We have moral beliefs because evolution produced them, moral intuitions, The feeling that cruelty is wrong, that fairness matters, that we should care for kin and cooperate with community members, are, from an evolutionary perspective, adaptations. They existed in our ancestors because individuals with those intuitions left more descendants than individuals without them. This evolutionary origin gives us no reason to think our moral beliefs track objective moral facts. Evolution selects for beliefs that promote reproductive success, not for beliefs that are true. If moral realism were true, if there really were objective moral facts, we would need an explanation for why evolution happened to produce beliefs that correspond to those facts. No such explanation is available. The evolutionary origin of moral intuitions is fully explained by their fitness benefits, without any reference to their tracking moral truth. Sharon Street, a philosopher at New York University, has made this argument with particular clarity. She calls it the Darwinian dilemma for moral realism. Either moral realism is false, or there is a massive and unexplained coincidence between the moral facts and the moral beliefs that evolution happened to produce. Given the absence of any mechanism by which evolution could track moral facts, the coincidence hypothesis is implausible. Therefore, moral realism is almost certainly false. These arguments do not mean that our moral commitments are worthless. They mean that our moral commitments are ours, products of our nature and culture and history, not discoveries of facts about the universe. This places the responsibility for morality entirely on human beings. We cannot appeal to moral facts that exist independently of us, and that would condemn certain actions even if no one cared. We have to acknowledge that the condemnation comes from us, from creatures with particular evolutionary histories, particular emotional architectures, particular cultural inheritances. Some find this liberating. If morality is ours to make, then we are responsible for it in a way that moral realism does not permit. We cannot blame the universe or the moral facts for the moral systems we build. We have to own them completely. Others find it vertigo-inducing. If there are no objective moral facts, then nothing is genuinely wrong in a universe-independent sense. The horror one feels at great cruelty is real, but it is our horror, a feature of our psychology, not a perception of an objective feature of the act. The universe is not wrong about anything. It simply continues. And we, the creatures who care about right and wrong, are alone with our caring in a universe that does not share it. Zeno's paradoxes were dismissed for 2,000 years as clever sophistry without serious philosophical content. The invention of calculus in the 17th century seemed to settle the matter. Convergent infinite series have finite sums, so crossing a room does not require infinite time. Case closed. Zeno refuted. Motion vindicated. Except the case was not closed, and Zeno was not refuted. What calculus did was provide a mathematical tool that correctly computes the outcomes of problems involving infinite subdivisions. It did not explain whether infinitely many tasks can actually be performed, or whether the mathematical formalism accurately describes physical reality at the relevant scales. The philosopher Adolf Grünbaum, writing in the 20th century, made the distinction between mathematical and physical infinity explicit. The mathematical resolution of Zeno's paradoxes works within the framework of real analysis, where the reals are a dense continuum and infinite series can converge. But whether physical space and time are genuinely continuous, whether they really are composed of infinitely many points between any 2 points, is an empirical question, not a mathematical one. And the answer from modern physics is genuinely uncertain. Quantum mechanics introduces a fundamental granularity at the Planck scale. The Planck length, 1.616 times 10 to the minus 35 meters, is thought to be the smallest meaningful distance. Below this scale, the smooth spacetime of general relativity breaks down, and quantum gravitational effects dominate. Whether space is truly continuous below the Planck length, or whether it is discrete, composed of some fundamental indivisible units, is one of the central open questions in quantum gravity. If space is discrete at the Planck scale, then Zeno's infinite subdivision of any finite distance reaches a flaw. You cannot subdivide Planck length intervals because there are no sub-Planck intervals. The infinite regress terminates. Zeno's paradoxes are avoided not by mathematical tricks about infinite sums, but by the physical graininess of reality. Loop quantum gravity, one of the leading approaches to quantum gravity, explicitly proposes discrete space-time. In this framework, area and volume are quantized. They take discrete values rather than continuous ones. Space itself is woven from a network of discrete excitations, and the notion of a smooth geometric continuum is an approximation that breaks down at fundamental scales. String theory, another leading approach, does not quite discretize space-time in the same way, but does introduce a fundamental length, the string length, below which the usual notions of geometry do not apply. In both cases, the smooth, infinite divisibility of space that Zeno's paradoxes presuppose may be a feature not of physical reality, but of the mathematical idealization we use to describe it. If physical reality is discrete at the Planck scale, then motion is not the continuous passage through infinitely many geometric points that Zeno imagined. It is something more like the sequential occupation of discrete space-time quanta. A particle moves not by crossing infinitely many positions, but by hopping from one minimal spatial unit to the next. The race between Achilles and the tortoise involves a finite, countable number of spatial steps, and Achilles finishes in a finite number of them. This would be, in a sense, the most satisfying possible resolution of Zeno's paradoxes. Not a mathematical workaround, but a physical answer. The reason Achilles catches the tortoise is not that infinite sums can converge, but that space is not infinitely divisible. There are only finitely many steps to take. But we do not know if this is true. The Planck scale is 20 orders of magnitude smaller than anything we can currently measure. Whether space is continuous or discrete at that scale is genuinely unknown. Quantum gravity experiments that could probe this question are decades away, if they are achievable at all. So the question Zeno raised in the 5th century BCE remains, in its deepest form, unanswered. Is space continuous or discrete? Is motion the crossing of infinitely many geometric points, or the occupation of finitely many physical positions? The mathematics says one thing. The physics may say another. And between them, in the gap where the two do not quite meet, the ancient paradoxes still have their teeth. Every movement you make, the rise and fall of your chest as you breathe, the turning of your head, the slow heaviness of approaching sleep, is, at the level of its most fundamental physical description, something we do not fully understand. Whether it happens continuously through an infinite geometric manifold or discretely through a sequence of quantized space-time states, the answer is not known. You move. That much is obvious. But what motion is, at the level where mathematics and physics meet at the Planck scale, is one of the questions that the universe has not yet finished telling us. 2,500 years after Zeno asked it, the question is still alive, still unresolved, still pointing at something about the nature of space and time that our understanding has not fully reached. That is what the best philosophical questions do. They outlive the eras that produced them. They survive every attempt to dissolve them. They remain, generation after generation, pointing at the places where reality exceeds our current understanding. Zeno pointed, "We are still looking." When Nozick published the Experience Machine thought experiment in 1974, most readers had the immediate intuition he was counting on. They would not plug in. But over the decades since, philosophers have pushed harder on this intuition and found that it is more complicated than it appears. Consider the intuition carefully. Why would you refuse? Nozick offered 3 reasons. First, you want to actually do things, not just have the experience of doing them. Second, you want to actually be a certain kind of person, not just feel as if you are. Third, you want contact with a deeper reality than a human-made simulation. The first reason, wanting to actually do things, is compelling for activities where the external achievement matters independently of the experience. Winning a race matters not just because of how it feels, but because you actually ran faster than everyone else. Discovering a theorem matters not just because of the satisfaction it produces, but because you actually extended human knowledge. Writing a novel matters not just because of the pride of authorship, but because you actually created a work that other real people can read. But for many of the things that make life valuable, love, friendship, beauty, understanding, it is less clear that the experience and the reality can be so cleanly separated. If you love someone, what you care about is the felt connection, the particular quality of being with that person. If the experience of that connection is indistinguishable from the real connection, is anything lost? Chalmers thinks not, or thinks that what is lost is merely a brute fact about the substrate, not a fact about anything that genuinely matters. If the simulated relationship has all the richness, reciprocity, and depth of a real one, then it is a real relationship, just implemented differently. But most people feel, when they press the intuition carefully, that something would be missing. The person you love in the simulation does not know you love them. They are not responding to you. Your love exists in a closed system with no genuine other. And for love, the genuine other seems essential. You want not just to feel loved, but to be loved, to have an actual mind out there in the world that is directed toward you. This points towards something that may be the deepest feature of what we value: genuine relationship. Not experience for its own sake, but experience in genuine contact with other genuine minds. The experience machine fails not because it substitutes artificial experience for real experience, but because it substitutes the experience of relationship for actual relationship. If this is right, then the thing we value most cannot be provided by any machine, however perfect. It requires the actual existence of other conscious beings, genuinely engaging with us across the gap between minds. It requires, in the most profound sense, that other people be real. Which brings us back to solipsism. If you cannot prove that anyone else is conscious, then you cannot guarantee that any of your relationships are genuine relationships in this sense. You might be in the experience machine already, not because a machine was built for you, but because the external world is, in some deep sense, a product of your own mind, and the other people in it are projections rather than genuine others. These two theories, the experience machine and solipsism, are mirror images. The experience machine asks, would you trade real relationship for the experience of relationship? Solipsism asks, how do you know you are not already doing so? The answer to both questions is the same. You act as if other minds are real, as if your relationships are genuine, as if the world is actual. Not because you can prove it, but because the alternative, acting as if nothing outside your own mind matters, is neither livable nor, in the end, something any honest examination of your experience recommends. You care about the people in your life. That care is real. The question of whether they are real is a question you cannot answer with certainty. But the care does not wait for the answer. It proceeds without it, as it always has, as it will again tomorrow.